with that, I'll go ahead and let this gentleman here take it away.
Okay, let's get started here. So my name is Tuukka Takala, and I'm from Aalto University. I'm going to talk about virtual reality and augmented reality. So quite a curveball that Bruce Orek threw us last night, about all the challenges we are facing regarding the climate change and fresh water, running out of the fresh water. If we're developing mobile games or the next Tinder, how does that help with these challenges? And that's really something to think about. As well as for my own kind of field, virtual reality, the only kind of justification I can think of is that with virtual reality we can maybe have some indirect effects, like virtual reality and augmented reality could work as tools to help us find solution to these impending problems. If anyone has any better justifications on how these fields can help, come talk to me after the talk.
Can I give a suggestion?
Sure.
On this question of mine? Using traveling. Once you can experience everything, being here, go to foreign countries without actually going there, that will actually reduce travel.
Yeah, okay, that's a good one.
Very simple one.
That's fast, thank you. And also virtual reality could be used for telepresence and more effective communications about issues and so forth. Okay, so this is the talk of, I'm going to talk a bit about me and my work with virtual reality. There's going to be an overview on VR and AR, and then I'm going to focus on how you can create VR or AR applications using the hardware that is available in this hackathon, specifically HTC Vive, Oculus Rift, Leap Motion, and Gear VR. So I've been in Helsinki University of Technology for quite a long time, and I've been working with VR full time since 2007. I'm a doctoral student in Aalto. I'm kind of wrapping up my studies, graduating next year if everything goes well. I've been teaching a VR course for the past 5 years for master and postgraduate students. I'm the author of Rui's Virtual Reality Toolkit for Unity. I've created a dozen or so VR applications, and I've been writing some scientific papers on the topic. My research subject is mostly full body interfaces for virtual reality. So the first thing, if someone experiences VR, they put the headset on, the first thing they're going to do, they're going to start looking for their hands. And the hands are not there unless they're being tracked with some device. So I'm focusing on this. We've been using Kinect and some other tracking software to get your body in virtual reality. And just to get an idea, I'm going to show a video of a recent VR experience that I have been creating with Kinect and Oculus Rift. So we're using Kinect for the body tracking, and the user wears Oculus Rift. So their body is tracked in full time. So if you have any kind of fear of heights or something like that, this is a very very immersive experience. We have tested this with some people. I remember there was one woman who just refused to walk over there. Even though the floor was completely even, we didn't even use a plank to kind of, and she just wouldn't go. Some people would go like this, whereas others would try to run over the virtual plank. So, and this is really having your body in the virtual reality is kind of next level stuff, in a sense that I think that right now the consumer versions that are coming out next year, HTC Vive and the Oculus Touch, they only have these kind of handheld controllers. So in the virtual world, you will only have your hands and your head, and not your whole body. It will probably take 2 years or so before this kind of Kinect-like tracking system become integrated with these consumer products. This is something we released in 2013. This was the first publicly available demo that used Oculus Rift DK1 and Kinect for similar kind of body tracking purpose. I've been also working with other input devices like PlayStation Move and created this kind of 3D user interfaces for, in this case, Blender, kind of combining the traditional 2D mouse interface with some novel 3D interface for Blender. I mean, this is virtual mirror, or more like augmented reality stuff. This was one project that we did in 2013, where the user can kind of change the texture pattern of the clothing they are wearing. And this is an image from a course that our students did using VR. Actually, I'm gonna show this to you. Well, let's see. No. Okay, something happened. So basically on the course, the students are free to create any kind of VR application. For some reason they always make games. But this is probably the best game we have had over the years. It's a 2-player game where one player drives a truck, another player is this bazooka guy on the pallet of the truck and shooting tanks with the bazooka. It was actually quite fun to play and quite fun to watch. And these guys have done nothing in VR, or nothing regarding VR before this course. Here is another application by our students based on a Japanese TV game show. So yeah, you're supposed to draw a kind of hole for your opponent. Your opponent has to go through the hole, and if you don't touch the wall, then you still have to go through your own hole to keep it fair. And if you manage to do that, you win that. Very simple, but surprisingly fun. This is very experimental virtual reality interface using a wheelchair. The idea was to kind of empower the user to do much more what you can do if you are on a wheelchair. And this is another cooperative game, something similar to Marble Madness and Super Monkey Ball, where the other player is controlling the ball and the other one is kind of helping This is also very much experimental curling game. So one, yeah, that's right. I don't know what, I think that guy is called the sweeper or something like that. And anyways, so it's always fun to see what the students create. Unfortunately, you guys don't have this much time. This was done over like many months, so so I expect that in a weekend it's not going to look like that necessarily. All right, let's move forward. So quickly about the toolkit that we have created. It's for Unity, it's free, it's open source, it's made with C#. It's being used by hobbyists, researchers, and students around the world. It's not like super popular, but our forum gets like regular intervals. There are people posting, making posts, so there are some people using it. And so what's the idea, or what's the purpose of the toolkit? We have the kind of noble goal of making VR application development easy for hobbyists, because there's a lot of challenges in VR, and the more developers we have, then like the quicker we can find solution to those problems. And traditionally, VR development has been very tricky and very challenging to get started. I mean, lately, when there has been these big players like Oculus and a lot of money, things have gotten easier, but it's still not as easy as it could be. So with this toolkit, we also want to facilitate the creation of novel 3D user interfaces. And how do we do that? We do it by offering or enabling the developers to use multiple different input and output devices simultaneously, which allows experimental interfaces. Currently, the most popular feature that we have is the Kinect avatar that you saw in the first video. And this is some hardware that we are currently supporting in the toolkit. The Oculus Rift models, Kinect 1 and 2, PlayStation Move, Razer Hydra, and hoping to add the HTC Vive and these other upcoming devices in the future. Okay, so let's get an overview of augmented and virtual reality. What is it? This kind of reality, virtuality continuum chart gives you a good idea what these terms mean. So on the other end, on the left, there's the reality. I've used this image of torso to represent reality. On the other end, there is full virtuality, essentially the matrix, where everything is virtual. Now in between, there is like varying degrees of virtuality being added on top of the reality. So there's augmented reality, where often you're using some kind of see-through display, and you have 3D objects augmented on top of that display. For example, Microsoft calls the HoloLens that is mixed reality, but you could call it augmented reality as well. And if you want to get technical, the Google Glass wasn't really augmented reality because that device didn't do 3D registration, so the virtual objects are kind of appear in correct places in 3D, so it didn't do the necessary tracking to be really called augmented reality. So a lot of things have changed over the years. In 2012, when I first met Palmer Luckey in a conference, this was before he had co-founded the Oculus company, and he was just kind of lab assistant in USC, and just a guy who had a very notable head-mounted display collection. And in spring 2012, when he talked to his, or mentioned to his colleagues that he's gonna start a company around VR, some of them kind of laughed him off, like, yeah, sure. And that's how bad the situation was. There wasn't really much traction for VR back then. And it was only after the Oculus Kickstarter campaign 2012, around August, hit it big. There some interest started to come around this topic. And in 2014, when Facebook bought Oculus, that's where things got really big. And nowadays we have these technology giants investing in VR and AR. And things are very, very different. You can feel the atmosphere in the conferences. Like 10 years ago, like it was pretty much dead. So, and now it's almost like the polar opposite. There's so much hype. It's ridiculous. And so you have all these forecasts, like multi-billion-dollar VR market in the next few years. I mean, sure, there's a lot of promise in entertainment, and many people hope that this stuff will also come big in let's say in AEC industry and other fields. And that's quite possible, especially with the augmented reality. Like eventually it will take several years, but like augmented reality devices will probably replace mobile phones. Like you don't want to be holding this thing when you have your glasses, and you don't have to like kind of occupy your hands with something. You're gonna be hands-free. But we are not, technology-wise, we are not still there, so it's gonna take some years. So augmented reality is gonna be really big, but there's still room for VR. And right now in Hollywood, there's interest in 360 degrees movies and these spherical movies, and the hype is, like I mentioned, the hype is huge, and I think we're gonna see disappointments that not all these like dreams are gonna come true, but we will see. So, okay, like a lot of people are talking about augmented reality and how big it's gonna be, but what's the use? Like, what's the benefit for us? So I'm gonna just throw you single examples about how you can use OR or VR. For example, this is I don't know. This is probably not the Boeing example, but Boeing and some other companies have used AR to help like the builders to build these engines that are very complex. And this stuff can also be used to train the workers and so forth. So this is one easy to grasp example for how to use AR in some kind of manufacturing work. In the case of virtual reality has been used by the automotive industry for kind of rapid prototyping, where you have the virtual representation of the car, and you're checking that like everything on the dashboard is within your reach, and if you need to make changes, it's much quicker and faster to make changes in the virtual model than to build a real prototype. So, and how these examples translate to AEC industry, I'll leave it up to you, but I'm sure you have good imagination. You can think of examples how you can use this stuff. I mean, traditionally, virtual reality has been used only for visualizations. You have the architect's model, and you're just kind of flying through the model, and you're seeing it from different perspectives. It's very visually oriented, very passive in a sense. And I think the biggest challenge is making it like more working in 3D, like interactively, not just watching the content. And how are you gonna work with the content in 3D? And kind of the natural interfaces for in VR and AR are kind of like spatial user interfaces. You're working in 3D space using your hands, and this is another like rabbit hole that goes very deep. It's a very like complex subject, like the user interfaces for virtual reality and augmented reality. And the reason is that right now there are no standard like spatial user input devices for VR and AR. It looks like there are going to be these handheld controllers. That is going to be some kind of standard, but it's still very much up in the air. In the case of traditional 2D user interfaces, you have the mouse and keyboard and some more rarer stuff, and those are very much like established. Everyone knows, or most people know how to use those. Second thing is that there are no standard interface or interaction metaphors for spatial user interfaces. In 2D UEs, there's like you have the WIMP, so-called WIMP interface. You have Windows icon, menus, pointing device, and not all that translates directly very well to 3D. So the whole field of user interfaces for VR and AR, it's tricky, it's up there. I think over the years, when these devices and technologies become more commonplace, we will find the kind of the middle way. Just as with mobile devices, we have these like simple 2D gestures that we use today. And one thing to point out is that the handheld controllers are much more precise and robust when it comes to tracking than when compared to gesture recognition. So if you have used Leap Motion, the device that tracks your fingers and your hands, it's pretty, well, frankly, it's shit. I mean, you don't want to use that for any real production tool. It's not. There are so many tracking errors, you just get frustrated. So, I mean, it's good for hackathons. You can make something cool and it looks nice. You can edit a video where everything is like this and it looks super effective, but the reality is still different, and it's gonna stay like that for a long time. And like, if you want to do something properly, you still need to use handheld controllers. They are much better for many purposes. The only like difference that I can think of is that if you're a surgeon and you have to get your hands inside someone's belly, and you cannot be touching like some VR controllers. In that case, probably this kind of like gesture recognition is better. When it comes to VR and AR, I have to mention cyber sickness. It's an issue. It's getting better, but some people are very sensitive to this. Like certain percentage of people, they can get dizzy. Like just in seconds. I've heard that people can even throw up. I haven't seen it, but if you get sick when you're trying Oculus Rift, then you probably should take it off. And if you want to get deeper in developing VR, and how to avoid cyber sickness, you should read the Oculus best practice guide. It's the best guide for kind of how to deal with cyber sickness right now. Okay, so let's go into the topic of creating VR and AR apps. Right now I'm going to mention these couple of different development platforms. There's Unity, Unreal Engine. You can use them for free. There's also WebVR. It's more like a JavaScript library that you can use. Right now it's a curiosity, but I think I should mention it. Then there are several C++ APIs for Oculus, for HTC Vive. There's the OpenVR. Also, Leap Motion has a C++ interface, and most of these devices have their own C++ APIs. For a hackathon, I recommend that you stick to Unity, unless you are already experienced with Unreal Engine. It's just really quick to prototype and do things in Unity. So let's quickly go through the WebVR, which is kind of interesting. Right now it only works on experimental builds of Firefox and Chrome. It's not clear if WebVR if it's gonna be like established thing like WebGL. But right now it's the best option there is. It's not difficult to imagine that in future we will be viewing virtual reality content in our browsers. And yeah, it's easy to think many cases where that will be useful. Here are some addresses that you might want to check out if you're interested. If you're using Oculus, you have to be aware that you cannot use the latest runtime for WebVR. And then there's HTC Vive that we have there. If you haven't tried it out yet, you can still throughout the day, I believe. I'll be here, and so the HTC Vive is right now it's better than Oculus Rift DK2 as far as like image quality goes and tracking. It's like full room size tracking. The tracking space that we have there, it's about 2.7 meters times 2.7 meters, almost 3 meters by 3 meters tracking space. And you have these two handheld controllers that you can interact the virtual reality. You can do development. Well, I've installed Unity in that computer, so the environment is ready. And one thing that you need is that you need a Steam account. You can get it for free. And yeah, I've already downloaded the plugin for Unity. I don't have Unreal Engine development experience. You can ask me about it, but probably I don't know how to answer. There are several, it's still very much beta software. There's a lot of kinks into it. It can easily, like you have to sometimes reinstall the drivers and restart the computer and stuff like this. So if you want to develop with this thing, come talk to me and I'll help you get started. But I mean, right now this is the best VR platform that we have, and it's really good, and you should come try it out. Then of course there's the Oculus Rift. Now I heard that we have DK1 and there's a possibility of getting DK2 as well. So you want to get started, or you want to use Windows, because the OS X development they have put stop to it for now. The latest runtime for OS X is version 0.5, whereas for Windows is 0.8. you should view the release note and make sure your GPU driver is the version is supported. And you should bear, if you're a laptop user, you might encounter some issues. There are some ways around it, but you might have to revert to older version of the runtime and run in the so-called extended mode. So again, if you have some issues, you can talk to me and I might be able to help with that. And the way you know that your system is working, if you're able to run the demo scene in the Oculus config utility. And with Unity, if you have the late 0.7 or 0.8 version, you need the latest Unity. You need to enable the VR support from the settings and so forth. Also, there's a wealth of information in Unity's own forum, in the virtual reality subforum, if you encounter any issues that there might be. Then there's also the Leap Motion device. I think Damon has that. You need to install the latest Leap Motion SDK. You can do some, you need to do some VR and AR stuff with the Leap Motion. Now, why am I talking about Leap Motion? I mean, I already called it shit before. I mean, it's good for demo stuff. It's okay for demo stuff. I think the combination of Oculus Rift DK2 plus Leap is a little better than just using the GRVR. Now, I'm not sure which Samsung device Damon has for the GRVR, but I believe it has like a camera, and you can get kind of AR view with the GRVR. But it's a monoscopic color camera. There's no gesture detection. There's really no spatial 3D position detection. Whereas with DK2 and Leap, there is some like limited positional tracking. The Leap is a stereoscopic camera. It's grayscale though, and it has like gesture detection. The best gestures that are recognized are kind of this kind of pushing gestures. The pinch gesture doesn't really work very well, so that's just a pointer. So if you want to do some right now, currently, if you want to do some experimental AR stuff, DK2 plus Leap Motion is a good way to go. Okay, I still have a couple of minutes. I'm gonna quickly show you guys, I think many of you are familiar with Unity. I'm gonna show you how you kind of import how you use Unity for these cases. So I have already imported different assets for I have very like bland scene that doesn't have anything special. So for Leap Motion, if you're using Leap Motion, the only thing you need to download the core assets package from the Leap Motion homepage. You just import that thing there and you're good to go. In case of Oculus, if you're using just the Oculus Rift, then you need to get the Oculus utilities from their website. And if you're using HTC Vive, then you have to go to Asset Store and you're gonna search for Stream VR. Oh, no, it's Steam, not Stream. No, please don't accumulate those. And here we go. And you're just gonna download this thing and it's gonna give you this folder here. So that's basically what you need to know. And when you have imported all this stuff here, let's say if I'm using Leap Motion with the Oculus Rift, I just open this folder here. There's the prefabs. I'm gonna drag and drop this LM head-mounted rig prefab into the scene, and I can choose what kind of setup I'm running. So basically, if I want like the AR world with AR hands, so it's gonna show you the camera, only the camera image, then I'm gonna set this, and there are these other options for VR world, AR hands, and so forth. And then I can run, let's see if this works. I mean, I don't have these devices connected right now, but you get the idea. Like now it's kind of working. And if I had the Oculus Rift with the leap motion attached to it, I could get the AR view here. So that's for the leap motion. If you're using just the Oculus Rift, then you go OVR folder. There's also the prefabs, and you get one of these prefabs. There's the plain camera rig, where the camera is kind of stationary. There's also the player controller, where you can get the kind of first-person controls for your character. And again, you just set up the prefab here in your scene, and you just hit play, and it should work. And finally, for the HTC Vive, there's the prefab folder. You get all these different prefabs, and you throw all of them here. Actually, I think you don't need the Steam VR, but anyway, in the camera rig, you have the different graphical representations of the controllers, and you can run the scene and so forth. So it's very straightforward to get started with this thing. And come ask me if you have any questions. Yeah, here's some contact info. Do you have any questions?
Yeah, very quickly, which of these devices can do AR? So which one has the camera? Or see-through optics?
None of these have see-through optics, but the GR/VR should have a camera. And then if you use Oculus Rift and Leap Motion attached to it, it also has like camera.
But it's black and white.
It's black and white, but I mean, in a way, it's better than the GR/VR, which has the color camera. But like the Oculus Rift and Leap Motion, it gives you the gesture. It's stereoscopic camera, and it gives you some gesture control stuff, and also some positional tracking.
In terms of input, have you played with some of the new body tracking units like the Prio VR?
Oh, I haven't. I'm familiar with them. What's your question?
I'm just curious how because you're doing so much work with Kinect.
Yeah.
I wonder if the Prio VR just allows you a much wider area.
Yes.
Greater movement capabilities.
The thing, as much as I understand Prio VR, you have to wear these gyroscopes. Okay, so basically it works everywhere. You could be riding a bicycle or parachuting out of plane, but it's not really tracking your position. So it doesn't, as far as I know, they don't have any external camera or anything, so it doesn't know when you're moving. It just knows the relative rotations of your joints, and you have to calibrate. Like you have to input how long your arms are. I'm not a big fan of those approaches because it's, you have to wear stuff and it gets very tiresome to put those things on. So I see that in the future this kind of Kinect-like tracking, like optical tracking is the way to go.
Okay, thank you, Tuukka. I think that Tuukka is going to be around for the day, so if you have other questions, go to Tuukka and ask directly. So now we have to move forward. So, thank you. So next one is going to be window positioning, and we have Samppa Turunen from Indo Atlas. Okay, please, Sampa, get started.
Yeah. So I'm Sampa from Indoor Atlas, and this session is about indoor positioning. And it was interesting to hear that the thing that it's actually a problem to know where a person is moving, for example, in a virtual environment. And what we have done is we have solved that problem already. But our solution works for mobile phones at the moment. And it is very interesting. We are living in interesting times because long time ago when GPS came around, no one really knew what to use of it. It was just giving position. And then after a while, it was obvious that we cannot even live without GPS. So it was a transformation to outdoors. Still, it doesn't work indoors. So now with our technology, we provide you the precision that is required to have actually good use cases indoors. Let's see this one. So, sorry. I have a video that doesn't show.
It just create skin, animation, color.
Okay. Sorry about that.
I'm trying to find my way out. I thought it was that way, but apparently not. It's okay, I've got my GPS on my phone. My GPS isn't working. Wouldn't it be cool if we could find our way around without using GPS? With like some kind of internal compass? Or to have something else that we can rely on? Hey Giles!
I pity humans having to rely on GPS technology. There's actually new technology being developed that can help humans navigate even when you can't access GPS. Can you guess how it works?
No, I can't, but I can guess that it's based on a certain animal.
I reckon you're heading in the right direction.
Bye, Giles. Hey, Robert, we need to find an animal that can inspire technology that can help humans navigate better.
That sounds like a really cool challenge. I'll get right on it.
Okay, and I'll try and find my way out of here. Bye, Robert. Did Giles say that way or that way? Or was it that way? Oh, hey, Robert. Oh, what have you found?
Well, I've just looked at some turtles. They are amazing at navigating.
So, how are they doing it then?
I think they must have some kind of sense that we haven't found yet that's actually allowing them to do that.
Take a look at this. It's an app called Indoor Atlas, which uses sensors in a smartphone to detect the magnetic fields in a building. And this is the man who helped design it, Vilat Kiamunkun.
Hi, Isabel. Hi, Robert.
Hi, Mr. Kiamunpoon. So, Indoor Atlas kind of does what a sea turtle can do.
Yes, scientists have discovered that animals have been using the Earth's magnetic field for navigation for many, many years. Birds use it in the sky, and also turtles and fish use it in the sea. It's based on that.
Ah, so it works deep inside buildings without needing satellites.
Every modern building is constructed with steel inside the wall, in the ceiling, and in the concrete. That steel causes magnetic anomalies to the Earth's magnetic field, and that is what is being measured and used.
Thanks Thanks, Mr. Kilmancoon. Bye.
Bye.
I've got to try this out. Okay, I'm back at the Mega Shopping Centre. Now let's try Indoor Atlas. It searches, and there I am. This is great!
Yeah, so the GPS has its challenges. It doesn't work indoors, and nowadays we know it doesn't even work outdoors in urban canyons. It's so dense area that you cannot actually see the satellite, so it doesn't even work outdoors there. But for our solution, actually the built environment is good. In the video it said that it is based on the magnetic fields. It's kind of funny because in the history, people were used to use a compass to find their way. So it pointed north, so they could steer their way and navigate outdoors. Then obviously we know now that it doesn't work indoors. There's so much, all kind of anomalies that the structure causes to the magnetic field that compass is useless. Still, the modern mobile phones has a compass chip within them that's built in. And you can use it outdoors, you can see compass and use it, but you cannot use it indoor. What we do is we utilize that feature. Basically the indoor world here and the anomalies caused to the Earth magnetic field, they are very constant. On this position, for example, the compass shows that, okay, north is there. When I move a bit, the compass is always showing a different direction. It's all going weird here. But it's always the same depending on the position. And what we do, we map those anomalies around this facility. For example, this floor has been mapped and then surveyed with the mobile phone sensors. So we know in our cloud service at which location the compass is wrong. And when the mobile phone moves through that magnetic field anomalies, we can pinpoint your location inside. Boom. Of course, we also utilize Wi-Fi positioning, but that's very inaccurate. That's kind of fast, but it gives you so approximate location that it's useless. Especially when there are lots of people inside the building or inside the venue, then it kind of doesn't work anymore. It works in laboratories and when the room is empty, but in real life it doesn't work. But still, we use all possible elements that can be monitored with the mobile phone in order to position the user. And the magnetic is kind of unique because it's everywhere. You cannot get rid of the Earth magnetic field. And that makes it kind of foundational layer. And even though it's not precise, if I position myself, I start positioning here, it's not a unique position yet. The compass doesn't give enough information to pinpoint me accurately to this location. But when the mobile phone moves a bit through the magnetic field, this path of anomalies is unique to this floor, for example. So then we know it exactly. So the accuracy when tracking a mobile phone comes from the magnetic field. And it's funny that there are actually animals using this magnetic positioning, and like birds and the sea turtle. And one big benefit of this is that it doesn't require anything to be installed. It is everywhere already. You don't have to have beacons or not necessarily Wi-Fi base station. You don't have to design the environment. It's zero hardware. And I think that kind of ties in nicely to the environmental challenge here. You don't have to build any stuff. I don't have anything here to give you. I don't have any stuff, but what I can give you is an SDK, and that can enable building applications on top of it. And it's super scalable. You don't have to deploy hardware, you just start using it. Of course, you have to do the fingerprinting or the mapping of the venue first, and then the facility is enabled. Our approach, in a way, and a mindset is that we want to share that information. It's not ours to keep. No one owns the magnetic field. It's everywhere. We just record it and give the service to everyone for the positioning. So we have a cloud-based service that gives to the end user the position. So when the mobile phone records the sensor values and sends them to the cloud answers from our service that you are there. And the magnetic landscape that we scan and that our customers scan and everyone scans, those are injected into a kind of one database that is shared with everyone. So we keep a global view of all the buildings in the world. That's our challenge, to map all the buildings in the world so that we have indoor positioning enabled everywhere. Yep.
Yeah, just a real quick announcement, pardon the interruption. We also are about, there was an announcement made in between, so forgive the interruption. There will be the 10 o'clock AEC workshops going on in the other room. So for the techies, definitely continue listening, but for anyone maybe on the AEC side, if you're curious to hear about how some of the technologies are being implemented and being used, that would be in the other room. Thank you and forgive the interruption.
This is also interesting for those guys.
Yeah, exactly.
As a company, I kind of skipped all the history and keep it short. I don't have time to go with that bullshit. Basically, we are just to say that we are live. It's used in Baidu in China. It's a big partner for us. Baidu is like Google in China, a huge mapping provider. So they have an app solution where the indoor positioning technology comes from us. So if you go to a mall in China that is mapped, then it's accurately located with our technology. And in South Korea, we have SK Planet, similar big organization, and they have a shopping application for malls that basically everyone has in their mobile phone because it has all the loyalty cards also in the same application. So when you go to the mall, the application runs, and then you can say, okay, I want to go there, or then it shows proximity advertising. And basically the proximity advertising is something kind of an obvious use case for this kind of stuff. I find it very boring and not intuitive at all. It's been there. Like, now I want here to kind of push you to do something else. And that's why actually we are here to investigate new opportunities with the construction and all different use cases. So there's search, point of interest, security, safety, logistics, maintenance. This is usable for all kinds of stuff. I don't want you to get stuck with these. Just to pinpoint that also it works underground because the Earth magnetic field is not stable underground. So it has similar anomalies caused by the ore and all the rock around it. So we have tested it in mining tunnels and it works well there. Although I have to say that it is a cloud solution, so you have to have internet access. So that's one thing. Yeah, our ambition, make every building in the world discoverable. And we enable it by giving the location of the user. I think this is something that we have long time thought that it's impossible to know accurately. Then there are many kind of attempts to solve the problem with beacons and Wi-Fi, and I now truly believe that it's now solved. Of course, we are in beta, and by the end of the year we will get rid of that. But I think then it is really going to happen that we have to think how to face the world now that it's going to transform. We can actually track the user. You can know your location inside without any other help. Let's try this one.
There are times in our lives when we know what we're looking for.
Yep, there are times in our lives we know what we're looking for.
There are times in our lives when we know what we're looking for and where we want to go, but just don't know how to get there. The compass is one of the greatest and most reliable navigation tools of all time and has been used by great explorers throughout the centuries. we decided to bring this trusted tool into the 21st century as an indoor positioning solution that's based on the anomalies found in magnetic fields, that universal, fundamental force of nature. Modern buildings all have a unique magnetic landscape produced by the natural geomagnetic fields that interact with their steel structures. By using your phone's built-in digital compass, our patented solution can use this magnetic landscape as a map for pinpointing locations indoors. Our cloud-based, software-only solution makes indoor positioning ubiquitous and available for everyone, opening a range of possibilities for app developers around the world. They can build location-based applications for a variety of uses such as social navigation, search, safety, gaming, and advertising. Indoor Atlas's game-changing indoor positioning service is now available for a range of iOS and Android devices and open to developers worldwide. Free your imagination and build your greatest location-based app today. Try it for free. Sign up at indooratlas.com.
To the stage, Indoor Atlas.
Oh, I'm going to... Sorry for that. So as I explained here, just a picture how it works. And the image there is an overlay of the magnetic field depicted that's measured and scanned. And then it's a magnetic map or landscape we talk about. Then in the mobile phone, there's a chip already that's measuring it. And then what we do is that we measure the whole path and the samples throughout it to pinpoint then exactly that you are here. Of course, in the very beginning, if you started here, like I said, it's not a unique location, there are lots of loops. But when you walk a bit, then that path starts to be unique on the landscape. So that's where you know where you are. In short, I think I have to reserve some time for Proximio, so I'm trying to be quick here. And how to get started. Now, focusing on this event, I hope that many developers start actually using the API. I'm proud to present that we have been working for half a year. A new version of the SDK 2.0 is now released. It's for Android and iOS. Of course, the Android is a bit more accurate because it has also the Wi-Fi capabilities, so I kind of push you to use that. It's easier. And then typically how this works is that first, we have to have some information about the facility in order to somehow pinpoint the measurements to a world coordinates. So how it's done is that a user or customer submits a floor plan. It doesn't have to be looking nice, but it has to be geometrically correct. And then aligning it on top of, for example, Google Maps application so that the corners of the building are correct. And then using that reference floor plan, we have a tool called Map Creator. You can download it from Play Store, and you can then, using the tool, do the measurements in order to enable the record the landscape. Of course, for this event, I saved your time a lot by already the first 2 points are done. So now it's just to go for it and then start making applications. So
it doesn't mean that Indoor Atlas API is not ready yet.
It is ready.
It's ready.
It is. And then here's how to get it. So you sign up, you configure, and you start using it.
And you're in that?
Yes. So like I said, the first two stuff are done. So this room, and I think this floor entirely, and the 6th floor sauna is working. I don't know about the sauna. You should go there with the mobile phone, but you can test it here. And I'm not that technical anymore, so for these technical questions, how to use it and how to compile it and how to make it work, please use the Slack channel provided, and then there is Jukka from Indoor Atlas focusing on the Android SDK and Seppo for the iOS SDK if you're using iOS. and we're happy to support you. Unfortunately, Jukka got sick, so he's remotely supporting you guys to work out and resolve all problems and questions you might have. And all this is you don't have to write it down because you should just go, just examples. I think I'm going to quickly go docs.indooratlas.com. Go there, it's all there. Questions?
If you have burning question.
Yeah, very burning question.
What's your business model?
Business model. It will come. Now we are serving kind of for free this stuff because our undertaking is to make it ubiquitous, working everywhere. So when you have business, when our customer has a business, when there is a lot of people and usage, then we have a monthly active user based pricing. So when you have an application that has many monthly active users, we price them that way. So of course it's free to use now and a long time.
Okay, thank you, Sappa. And then we have other Finnish company on indoor positioning, Proximio, telling shortly about their solution. And Sappa, will you be around here?
Yeah, I will be here now in the morning, and if you have questions, I can answer and we can discuss, yes. And then tomorrow I'll come afternoon to check out how it's going. But I will be also in the Slack.
And we have this indoor positioning challenge in the hackathon. So if you are using these kind of indoor texts, you can participate.
Who's doing that in a challenge?
Sorry?
Who is doing indoor positioning challenge?
In this AEC hackathon, we have different challenges. So one of the challenges to how to
we also need that in our challenge. So we would like to compete with them.
I mean that you don't have to worry about that.
You can mix and match.
You can do whatever you want, and the jury will be judging that the prizes and different challenges. But let's, Annina.
Okay, so hi everyone, I'm Annina Koskela from Proximi.io, and Proximi.io is actually what comes after Indoor Atlas. We're the next step in the development process. When you start with these technologies, the next few steps, or the remaining steps to your application, in terms of how you're going to use the location data, that's where Proximi.io comes along. We want to make it as easy as possible for you to use this location information and create some really amazing apps. So this is what we do. What we have created is a platform that brings together all the existing mobile navigation technologies under one single technology agnostic API. So the first thing is easy access to all these technologies. We support iBeacons, Eddystone beacons, and just to mention, we have some Contact.io Eddystone beacons there if you want to use them in your projects. Then we support Indoor Atlas. Unfortunately, Indoor Atlas just released a new SDK 2 days ago, so we're not on top of the development, but we're in their previous version, which is fully functioning as well, and so no problem with that. And then we support the native location, meaning GPS, cellular, and Wi-Fi navigation. And on the platform, you can combine those different location technologies however you wish, and create apps that function seamlessly indoors and outdoors. You can even add new location technologies to your project as the project advances without requiring any updates to the program code itself. So that's first thing, easy access to location technologies. And the second thing is how you're going to use that data. Knowing where the end user is with their mobile phone, what's going to happen next. So this picture tries to illustrate that. We call it the if here then that engine. So here's the end user who has an application on their phone. It can be an existing application or a new application that has the Proximi.io framework in it. And the framework will pick up all these location signals and send the information to our portal through the application. And on the platform, you can define different geofences, meaning interest areas, where will happen something when the end user walks into that area. And that something could be something that takes place back on his mobile device, Or it could be an external action, something that happens in a third-party API, something that is not visible to the end user at all. And on top of that, we collect anonymous analytics about everything that takes place there. It's just showing a bit more about what it could be. So mobile actions could be a push message or advertising. So this is what Sampa called the boring uses for the location data. It's very popular for retailers, but it's quite standard. So what would be more exciting could be these external integrations to social media, or it could be connections to IoT devices, for example, digital screens. You can show different things to each passerby. You can recognize the passerby based on their location and then target advertisement or whatever for them. And then we've got the analytics. You can see exactly where people have been moving within your premises and outside of them. And on top of that, as we are a service that is made for developers and we want to keep everything as open, as flexible as possible, we also have REST API, and you can use the information however you wish, even if you don't want to use any of this system, and just maybe, for example, to see how many people are in a room at that moment. That's also possible. So what we actually have is the SDKs. We've got native Android and iOS SDKs, and then we've got a Cordova plugin for different developers. And those SDKs include demo apps that are completely freeware, so you can just start creating on top of that. Those exist for iOS, Android, and Ionic. We also have a WordPress plugin that is our newest feature that is just out. With that, you can use some of the location-based triggering and activity through mobile websites. We can talk about that individually with you guys later on if you're interested in that. And then we have the front end, a web portal where you actually control all these different technologies and the geofences and the actions. So all of that happens on the portal, so you can update it on the fly without any updates to the actual application. And it doesn't really require any programming skills either. It's just very drag and drop based tools. I'll just show you 2 use cases to give you an idea of how you could use Proximy.io. This is a boring use case. We did a pilot with the Vantaa Art Museum close to the airport. And they had an exhibition where we used 10 iBeacons attached to different locations in the museum next to different artworks, so that when the visitors came to the museum, they got a little welcome message and then information about the different artworks to their mobile phone. And then maybe a bit more interesting use case is what we're doing currently with a Finnish company called Telinekymppi. They're a company focusing on scaffolding, renting and installing scaffolding. But in addition to these large, massive installations, they also have smaller items like pallet wagons and that sort of stuff that easily gets misplaced in construction sites. And they've tried different sorts of methods of tracking these wagons to see where they're moving, but those haven't worked. So what we're now solving the problem with is by attaching some Contact.io tough beacons that are weatherproof beacons to the pallet wagons. And instead of controlling people, we'll be actually tracking people, we'll be tracking the wagons. We have imported the wagons into our system through the API as the anonymous visitors. And then we'll keep checking their location through an application that is downloaded to the mobile devices of the Telinekymppi staff, the construction site managers, and other key people involved in the process. So when these wagons are dropped off at the construction site, their location is updated to our portal through the app. And whenever somebody moves them to a different place in the construction site or even to another construction site, we'll be able to see that through the mobile device of the person who moved them. Because the thing is that these wagons don't get stolen, they just get misplaced because they move around so easily and people forget where they put them. So now we'll be able to keep an eye on that better. And yeah, that was just 2 cases, so we'll be really excited to see what you guys can come up with. I'm not sure if we have a couple more minutes. If Mika, you want to say something?
Yeah, I'm here for more technology questions. I've actually set up a demo account for the AEC. There should be a URL in the Slack for the AEC page, which is over here. I've actually also built a demo application for the AEC, and it's actually linked to the demo account which I created for this venue. And basically, you can download the demo application from our website. What it does is basically gathers your location information throughout the venue, and it actually syncs all the data to our backend, and you can actually see all the nice resolution. 1 second. Here we go. I didn't change. So basically, it sends events to our backend when you move along throughout the venue, and you can also manage all the Eddystone beacons we got there. There's 6 of them. So you can actually manage them here. So these are all in the box over there, and you can scatter them around any way you want. And basically, there should be some analytics already coming in. Let's see. So yeah, here's the venue, and basically it's gathering location data based on the Eddystone beacons and Indoor Atlas plus our mobile applications. So I actually have one in my pocket, so it should be gathering nice data. And basically what you can do with it, we have SDKs as Anina mentioned, but also on top of SDKs you can actually use, let's say, Node.js or anything like that to leverage the real-time data which comes in. So for example, if you approach nearby the Eddystone beacon, you can actually tap in to real-time data for entering and exiting the area. So for example, you could do the digital signage info screen with a personalized message when a customer enters the area or anything like that. And we also, let's see how it works. These Eddystone beacons have sensors inside them. There's a temperature sensor, acceleration sensor. So basically, you should be able to tap in. Let's see if this works. So as you can see over here, when you click on the Eddystone beacon, the mobile application with our SDK has been syncing the temperature, which is 27 degrees, and also the battery voltage, so you can see if it's running out of battery. So maybe you can leverage the temperature, which is real time as well. Any questions?
Do you want to show the orchestrator tool?
Yeah, we actually have a tool called Orchestrator, which is integration tool for building complex logic visually. I do have one account available in case someone wants to use it. It's a Node.js based visual editor. We have quite a lot of different modules to use, and you can basically monitor temperature changes or maybe even real-time events of places when used like this one. So you can use this one to build quite nice logics, which can include stuff like Twitter integration, Facebook, CRM, external RESTful APIs, you name it. I have one account available for this one, but basically it's based on Sheets, so multiple teams can actually use it with the same account in case required.
Well, I have a question.
Yeah.
You have the picture from the scaffoldings outside the building.
Yeah.
Can your solution be used like outdoors as well?
Yeah, sure. Our technical stack actually includes native location services as well, which consists of GPS, Wi-Fi, etc. So yeah, definitely, it's indoors and outdoors. So.
Okay. So you can move from indoors to outdoors. And
yeah, and actually, as we have the older Indoor Atlas SDK inside our framework, basically it didn't have support for changing venues in real time. So what we did, we actually assisted the Indoor Atlas SDK throughout our framework to detect which place you are So for example, if you move from here, let's say Helsinki's camping or something, we tell the Indoor Atlas, change the venue. So yeah, it should be quite seamless. Yeah, and actually you can also trigger venue changes using iBeacons or Redstone beacons as well, but also GPS.
Okay, if we think about venue size of a construction site, do you have to track it first?
Depends. If you use Redstone beacons, iBeacons, no, you just place the beacons inside the venue. With GPS, that's the same thing. You don't have to map the venue, but if you want to use Indoor Atlas, you have to map the venue or have someone to map it for you, like this in this case. So basically, this venue is already mapped by the Indoor Atlas, so you can just link the Indoor Atlas account to our backend and start using the data without remapping the venue.
Okay, any other questions? Okay, thank you, Annina and Mika.
Thank you.
So, if you mentioned that are you going to stay here?
Oh yeah, we're gonna stay here for some hours.
Yeah.
If you have any
Okay.
questions, and then afterwards through the Slack channel we'll be happy to help.
Excellent. And next one is Pasi Jokinen from Thingsy. Are you ready? 10 seconds. Okay, just want to mention that we have Thingsies for if you want to develop on using Thingsies. We have still some Thingsies left, and we have also 5 Thingsies for prizes, which Thingsy has. Thingsy wants, which is the actual device. There are Thingsy has provided those as a prize. For the hackathon.
Yeah. It'll be here around, let's say. So I'm around for the next few hours. So. Yeah.
That sounds bad. Se on täällä päin. Audio menee tää tuo pois siksi en ole audio. Mitä sä aloitat?
Tässä on näin.
No, happy with that.
Kaksi ei ole. Tää vissi jotain. Joo.
Joo, ei vaadata.
Joo, tämä. Ilmeisesti jotain.
Yeah. Actually, we're actually using it at the moment. Heat maps are actually our main way of visualizing people flow.
Okay.
Especially with Indoor Atlas, it's really nice because we can actually take, because we can actually take quite a lot of samples. So for example, in here, this is one of the users, probably myself.
Okay, so hello everybody. My name is Pasi Jokinen. I am the CEO of Thingsy Ltd. We're a company from Oulu, and we develop tools for developers to build new Internet of Things solutions. Our first product is here, the Thingsy One, which is a smart sensor device to work as a basis to build your own IoT application services or even prototype new kinds of devices. If I talk a bit about the reasons why we started building Thingsy One, a couple of years ago, our parent company Haltian started to develop a system for Wärtsilä that would track these very valuable shipments worth millions of dollars all over the world. So they needed a hardware platform that could log such things as GPS location, impacts, and changes in temperature, and so on for long periods of time, and then send that data over cellular networks to Wärtsilä data centers to know what kind of, if there's been any kind of problems or bumps on the road and so on. And during this time, we noticed that even developing these very simple hardware devices with cellular connectivity costs a lot. So creating a new device with cellular connectivity, doing the whole hardware development process and taking the device through certifications, FCC certification, IC certification, CE certifications, and everything, that costs $1 to $2 million if you want cellular connectivity. And seeing that pretty much all of the internet wasn't developed by people who had access to $2 million. It was developed by people who had access to a computer in their dorm rooms. It kind of pissed us off. We wanted IoT to be a place that where innovation is created by individual people and not only by companies with access to huge resources. So our idea with Thingsy One was that we want to create a platform that with a couple of $100 anyone can start using and start trying out their own things. Maybe even build a company, prototype a company before they go to, let's say, investors to get more money, or build some kind of use case for friends and family, whatever, with a small investments. So what is Thingsy? Thingsy is a device that has cellular connectivity, 2G connectivity, Wi-Fi, and Bluetooth, and it has accelerometer, GPS location, a gyroscope, sensors for temperature, humidity, air pressure, and ambient light. It's not a dumb machine. It's not just a thing that measures stuff. It's got a smart state machine that you can actually program it to work quite smart. We'll go into detail a bit later. But the idea is that we wanted to give you all the possible tools we can to start getting data in smart ways from the real world and start building applications against the data. The one hardware speciality that Thingsy has, if you look at the sensors, you can find pretty much the same sensors in any cell phone. Like, I'm pretty sure that there's only a couple of you that don't have these sensors already in your pockets. So what justifies the $300 price point that Thingsy has? It's that we can go for more than 1 year with one battery cycle. So if you, let's say, take temperature, humidity, and location information a couple of times a day, we can do that for around 600 days. If you take orientation information live all the time, reading it all the time, this won't last more than, let's say, a couple of hours, let's say more than 6 hours. But if you're smart about it, and we really try to help you be smart about it, you can go for long, long times. ThingsE1 is open source, so we've got an operating system that we call ThingsE OS. It's based on a real-time operating system called NotX, which is totally open source. You can go and grab the source code. We are on GitHub. ThingsE SDK has the device firmware, but we're not expecting most of you to be embedded developers. We're expecting most of you to, at most, have experience of web development or scripting languages or not even that. But if you want to, you can go grab our SDK and just rewrite our firmware to totally do what you want exactly. But if you don't want to, we got something for you too. So this is what we call ThingsE Creator. As I said, ThingsE1 is a smart device. It has a rules engine that can change its own way of working dynamically. But to understand, let's do something very simple. This is a temperature logger. The point here, what we're trying to achieve is to measure temperature using ThingsE1 and to send that temperature information to a server, some server somewhere. So this is the our configuration utility. We have a task called temperature log. This could be anything. Here we selected the environmental measurements. So we're measuring temperature every 50 minutes, logging that stuff to the device. But also we're sending that event to the cloud. So sending it to the cloud means our cloud implementation, but you can also send that data to any server anywhere. So if you have your own server, you could get the data delivered there. So this is it. You define what data you want, how often do you want it, and what do you want to happen to the data. So that's a temperature logger. Let's do something a bit more complex. So as I said, this is a state machine. So in here we have two different distinct states. So this low limit state and above limit state. Just one state is active at one time, but each state can have multiple tasks running parallel. So I could add multiple different tasks here, doing different things, measuring different things. But right now I have only one task. So we're measuring speed information every 15 seconds, and only if the, can you guys see this, by the way? Only if the speed measured is over 120 kilometers an hour, we'll send an event to the cloud. We'll switch to the above limit state, change active state to above limit. And at the same time, we'll send a text message saying that the kid is speeding. That's my phone number, by the way. And yeah, what happens if when the kid is speeding, going past 120 kilometers an hour, the device switches over to this state. And in the above limit state, we're having a speed measurement also every 10 seconds, checking if the speed falls below 117 kilometers. The reason this isn't 120 is that there are small variations in GPS accuracy. So it might be jumping between 19 and 20. Well, the guy's actually driving quite steadily, and we don't want it to change the state like randomly all the time. So the idea is that every time the speed goes past 120, we'll go here, get the text message, get the data event, and when it falls below, we'll go back. If we only have one state, with this one, we'd be getting the text message on every single measurement where the speed is past 120 kilometers an hour. So how do we enable these? So we'll do a send to device. So here I have a device. I'll activate this speeding alert purpose. The next time the device phones home, it'll activate this usage profile. We call these purposes. Or I can manually do the update from the device. But let's do one more. So here we're utilizing a bit more stuff. We have 3 different states, and the idea for this purpose is to create a theft alarm system that magically can wait and listen for, let's say, in your car, waiting for somebody to come in and steal it, and it'll give you an alert when needed. So we have 3 different states. A sleeping state that consumes almost no power. It can go for around 400 to 600 days staying in this state with no problems. Then we have an area check state and a tracking state. The point is that if it's not stolen, we're here. This detects if it's stolen, and if it's stolen, we go here and get location information. And let's see what this has eaten. So at first we have an impact threshold. So the device is waiting for, let's say, a 0.3 G impact. So when the car is not moving, the car is just parked somewhere, the device is not doing anything. But then it detects an impact. Let's say somebody opens the door and starts driving. We detect a small impact. What we do is we go to the area check state, which is this one here. And within the area check state, we have enabled geofencing. So we're enabled geofence, trigger if outside geofence. These are something that you can draw free form. So if the device is outside this geofence, we trigger changing active state to tracking, and also we send a text message saying your thingy has been stolen. This could be a custom event sent to your own server saying you could do something custom there. You get the exact data. So when this happened, you would get data about the location and that the device has left the geofence. So in the third state, we have report location. So we've just turned on location information. We're measuring that every 15 minutes and sending that data to the cloud. So when latitude sensor has any value, longitude sensor has any value, send event to cloud and send event as push notification. We have a mobile app that you can receive these push notifications. So, all in all, the idea is we want to stay here as long as possible because this consumes almost no energy. It can stay there for 400 days, 600 days. This is the smart part, so we get a bump. If we are not where we're supposed to be, we go here. This is the opposite actually. If we are where we're supposed to be, we'll just go back to the sleeping state. And let's just say that just for some dumb reason, there was a GPS glitch or whatever that we ended up in the stolen state. We have an in-area check here also that if we actually are where we're supposed to be, we'll just change the active states to sleeping, and we're in energy efficiency mode again. These names are just something that you can create free from. As the same goes with the tasks themselves. And some logic to this. Within, let's say, the within one task, all the selections you have made. Let's say we're measuring impact, but let's turn on to temperature also. This is pretty much the important part. So I've decided that I want an event when impact is over 0.3 Gs and when temperature is over 11 Celsius. This is the important part. You'll only get an event when these both are true at the same time. When there's an impact of over 0.3 Gs and the temperature is over 11 Celsius. So these only happen when all of these are true. If you want to do parallel things, you don't stick them all into one task. You'll do parallel tasks. So if you want a separate event to the cloud when there's an impact of 0.3 Gs, you'll just do this, send event to the cloud, even URL if you want to, and then you do a different parallel task for the other sensor. Like that. If you were to shove everything into one task, let's say we put temperature, humidity, and we'll set thresholds for every single one. You would only get an event to the server when all of this stuff is done, all of it. So what can you do with this stuff? Well, pretty much any, well not any, but a lot of different services. So you can use this stuff just to gather data if you need to. If you're just interested in getting environmental data, we have a small, simple UI for getting map data and information about all the measurements that the device can do. I don't have any data coming into the server right now, so this is empty. But this is not the point. The point is for creating new kinds of services, new kinds of applications. I don't know, maybe a hackathon would be a good place to create these kinds of new services. One thing I did, we did, is this dashboard. Let's see if I can put the thing on, just a second. one of these should be providing me with information, but apparently it's not working right now. We'll do the.
How long would the battery last if you want to, like, once an hour get your location, temperature, the lighting conditions?
A couple of months.
Couple of months.
Yeah. So the one that we have best information is measuring location and environmental information. So humidity, air pressure, and temperature 2 times a day, and that's going to last somewhere around 400 to 600 days. So it'll be linear. So if you like do 6 times as many measurements, it's going to drop to around 1/6.
So the GPS is expensive.
GPS is like very expensive. Gyroscope, which actually doesn't work properly right now, is the most expensive. But GPS is middle of the road. Yeah.
So basically, the efficient way would be to do this impact thing and only then send position when it's actually moving.
You can actually do, yeah, that is smart. But if you're not if you're never moving, you'll do a clock-based thing. So if you're, we can do this smartly. So if you just define that you want location information every 12 hours, we'll be turning off the GPS for 11 hours and 59 minutes and whatever.
Will you still send it even if the position hasn't changed? Can you do that?
Yeah, this will do that. If you yeah, exactly. There are some impacts if you do this and only send this every 12 hours. It'll lose the GPS fix, and the first data you get might be quite crap. So we do have this accuracy information from GPS. So you could do 2 different states where you have, let's say, the first state doing. Let's just create a new one just a sec. So we'll have a first state that does location information by accuracy, and if the accuracy is under, let's say, 100 meters or 20 meters, we'll do, I have to actually create the state first. Add state. Actually, we need a third one, so location. So, if you really want very accurate information, we'll do just measure location. This can be anything basically. Action, change state to sleep. Send to cloud. Here we have just a clock-based timer. Let's do 3,600 seconds, after which we switch to accuracy. And in accuracy, yeah, exactly. So trigger if under 20 meters and change to location.
How does the device know that it is accurate?
That's like GPS. GPS provides information about the GPS chip provides information about the accuracy of its own data. You can actually do, if you want to do this all server side, you can enable the location and accuracy information at the same time, and you could do the intelligence back on the back end. But this way, it'll stay sleeping most of the time, then get GPS fix, and as long as you get like accurate enough information, which here provide you with one GPS location and then go back to sleep. So
the most efficient would be to replace sleep with the accelerometer.
That's the, so we have 4 low power sensors: the real-time clock, the accelerometer, ambient light sensor, and Bluetooth proximity sensors, which are enabled here on the UI. But any one of those, like real-time clock, so clock-based timer, an impact or ambient light-based threshold will consume almost no energy whatsoever.
But you could do with 2 states, basically going to the moving state and then make another room to go back to the sleep state.
Yep.
The accelerometer.
Yep.
And you can do like, if it's 10 seconds in place, you go back to sleep.
Yeah, can do.
What about the package? I looked at this beforehand. So can you do multiple? If I want the user to keep his own kind of backend or the backend, but I want to add another one, which is mine.
Yep.
So you can push the 2 backends.
Yeah, so there are multiple options here. The API documentation, I'm going to provide you with, on the Slack channel, if you want more information about Thingsy, I'm going to post links to API documentation and everything and give you help on the Thingsy Slack channel on the, over here, the AEC Hackathon. Thingsy channel is the place to provide you with information. But the question was, how do you hook up to the data? What are the ways to hook up to the data? And I showed you previously that you can get the HTTP post being sent to your own servers, and you can do whatever you want with them there. But if you send the data to our servers to the default, if you do this send event to cloud, that'll end up on our servers. And we have a REST API, a website socket API, and an MQTT API to this our cloud implementation. It's going to be a bit slower, so if you need like really fast data within the second that it happens, you might want to send the data straight to your own server. But if that's not needed, you can send the data to our server and then use this documentation to see how to get the data out of our server and to your own. Also, I have a Node.js application example, proxy example here on our GitHub. So it's the 3D demo that I couldn't get working because the purpose was forked. I'm going to give you a live example on the Thingsy Slack channel later on. But here we have the 3D demo. You can download that. It also has a very simple proxy implementation for a custom server. What this basically does is, this is the part where it listens to posts happening to the path of settings API path. It gets the data from Thingsy, and this is the part where it does the magic. So if you want to save the data to a file, this here is where you would do that. If you want, in our proxy example, it just provides a REST API and then sends all the data that it gets to a WebSocket connection for whomever subscribes to that data. That's very stupid and simple. So here we get a WebSocket client waiting for Thingsy device data, and if certain Thingsy with a certain device UUID connects and sends data, we'll just send the data to whomever asked for that data from that specific device. This has no authentication, authorization, any kind of security whatsoever. This is just a plain HTTP API, listening to posts to one particular address, and then sending that forward over WebSockets. So, any questions at this point? Okay, a couple of things about the devices that we've shared here. They're equipped with DNA SIM cards that we're currently having some trouble with. Is Maria here? Maria? No. She's trying to find out what the problem is. But if there is a problem with the devices, if you're using the DNA SIM cards, if we haven't had the problem solved as of now, you can use any Wi-Fi connection, like proxy through your own cell phone, like I'm doing right now. And until that, we'll try to get the SIM card issue fixed.
If the user goes to your LinkedIn cloud, how did I get access? Did it need to give me some token?
Yeah. So, excellent question. So,
how does the user come get
So, to use the Thingsy cloud, you go to app.thingsy.com and you register there. So you register here, create your own account, and then if you want to get data from here through the API, the API description does tell how to do this. By using that information, you want to do an authentication event and get a token. You'll get a token back that you can use to request more data. So we have. So you don't have. There is no way currently to get data from a device you don't own if you don't have the credentials for. Yeah.
You could build your own service on top of
Yeah, you could build an own server on top of this, or just have it being sent anywhere.
Right. Okay.
So I'm going to post a link to the Slack channel in a couple of minutes that has how to get started information, and you can ask me anything. We'll be staying here and we'll be hanging out in the Slack channel if you have any questions about Thingsy. We're also going to post a discount to everybody here, so if you want to buy your own Thingsy, we're going to give you a significant discount on the Slack channel, and yeah, I guess that's it, right?
Okay, thank you. We still have time for 5 minutes, and okay.
Ei mennä. Meillä on varmaan laitteita vielä jäljellä. Onko kuinka monta laitetta jäljellä? On jäljellä.
Me voitaisiin ottaa yksi.
Joo. Noniin,
päästään heittää sitä.
Noniin, hyvä on.
Ja on meillä fallbackia se oma. Tuotiin oma.
Aleksi Taipale somewhere here. He's from Unreal and he's going to present their stuff, and we are waiting for him. So now you 2 minutes.
2 minutes. Okay, so he's recording.
As you change the location, you should probably reassign the places, because people, the speakers don't really connect location of the model. So for example, this is that one. So if you move around the beacon.
Okay, so we take one and then we move around.
So you should probably just drag and drop a beacon on top of that, because this way we can actually know where the beacon is. So we can do some nice stuff with analytics, etc. And the temperature information is
okay, I can just
using the application from here.
So I'm working for Autodesk, and I'm here today to introduce an API to bring 3D on the web. So if you have a website or any OS application you have on mobile, we have a 3D WebGL viewer, which is open source, that you can embed into your application. And the advantage of this technology is you can see any 2D or 3D file format on the web without any piece of software on your desktop or mobile application. So it comes with an API, so you can customize the viewer as well as you can customize the content in the viewer. So it will give you access to everything that you see. So if you want to change material, if you want to move stuff, there is API to do that. So if you're interested by using this API in your hack, then you're welcome to me. I'll explain in more detail what it is. So we're running out of time, so I won't demo it. But it's a JavaScript API, so very, very easy to embed into your application. And again, it can read anything you want. So whether you have Rhino, Revit, files, you can bring that into the viewer, and you can get full access to the data. So it has all the geometry, all the metadata you can get in, and you can link it to external database if you want. So if you're interested, just come to me. And there is another guy here who's working with me, so he can help you as well in your hack if you're interested. Okay? So now, if my computer started, no? So if you want to see it in action, just come to me when my computer is back online. Thank you.
Okay, thanks.
Sorry.
No problem. 2 minutes slot.
You told me 2 minutes, so I rushed.
Okay. But then I think I welcome Aleksi Taipale and Andrea presenters. Also, person.
Is there HD?
All right. Hello, everyone. I'm Aleksi Taipale. This is Tuomas Kankaanpään. We're Unrealer, and we're presenting you a Matterport demo. It's a technology that our company uses, and might be of interest to you. So we have a demo here. So just a quick overview of Unrealer. We're a company founded in last year, and we offer marketing solutions for the real estate as a service. And our agenda has been that we look for the best technologies globally and bring them, at least for now, to Finland, but probably to Scandinavia and wider audience as a service, since the technologies don't come here by themselves usually. So the whole thing started, we saw Matterport technology last year, and we thought it was really cool, and we got the camera here, and we started doing business with real estate agents and construction companies and property owners here. But pretty quickly we've kind of widened our offering for real estate. We do 3D modeling as well. We're partnered up with Floored. It's a company in New York, and Archaeologic, which is a company in Switzerland, I think. And we're also offering those services to our customers. And then we also do video and photography. So we're kind of like a full-scale solution if you want to market your property. So we're not in the exactly in the construction side. We're mostly in the business and marketing side. But we want to present you the Matterport technology, which might be interesting for you in this hackathon. Okay, so I don't know how many of you have heard about Matterport, but it's actually a pretty cool technology. I will show you just after this, like what it actually can do. But what it actually is like, or what's the vision of Matterport, it's like the most immersive way to experience a space. And it's a super quick, easy, and cheap way to do a 3D model of any space. It's only used for existing spaces, so it's a capturing technology. But currently it's mostly targeted to residential markets, since there are limitations with the technology on how big of a space it can capture. And it was launched 2014 last year when we started, and it has evolved a lot, the technology, but it's still the same device, the device on the right that we use to capture the spaces. And just a quick overview how it works. It's a camera that has 3D sensors, depth sensors, infrared sensors that capture the 3D mesh. And there are also regular cameras that texture or see what's like capture regular camera data. And the whole thing is operated on a tripod with an iPad, and you press a button on an iPad and it rotates and captures each spot, and then you move it to the next spot. And it's really easy to use. It's a super user-friendly device, so it doesn't need any expertise. And once you've captured a space like this might take an hour to capture. And once you've done that, you upload the data from the iPad to Matterport Cloud, which processes it. And as an output, you get the Matterport Showcase. I'll show you just in a second. And also like a OBJ file, which is like a full 3D model of the space. And here's just I think what is most interesting about Matterport is the cost versus quality. It's or how easy it is to do one scan. It's like approximately 1 hour to do 200 square meters, and the gear is like $5,000, but it's only like $19 per model to do, and it takes 1 hour. So you can calculate that we can operate to our clients for pretty close to the price of doing photography on a house. It's like the same price, and you get a full 3D model where you can actually move around. Okay, and now we're going to show you some demos. So we'll first show you the Matterport Showcase, which is Matterport's kind of a combination of 3D model and like the spherical photography data. So it's like, since the 3D model is not super accurate, so you see only like the really sharp image of the space, but you limit the movability. And then we show you the actual 3D model, and then we show a little video of what Matterport has been working with lately. And then we have a bunch of time for questions, since we don't know what you exactly want to know. So, oh, interesting. Okay, so here is, if you want to show it around there, here's the 3D showcase, like the Matterport's main product, which is the 3D model is combined with the photo data. So actually what you see is very accurate and it's really realistic since it's the photo data, but there's also the depth data underneath everything, so you kind of see like how the mouse goes, like it senses the space, although it's using only the photo data. And in the showcase there's the 3D model view option, so you can view the 3D model from afar, but you can't really go in there, or when you go in there you move into the photo data. So this is actually about the history of Matterport. They first had the player only work with the 3D data, but for real estate business it wasn't, especially for residential business, it wasn't like selling enough. It's not like super, or it's pretty nice quality, but it wasn't selling houses, so they had to kind of pivoted a little bit, and now they have this kind of solution, and there are a lot of users in the US. I think they've sold more than almost 2,000 cameras in the US, and a lot of residential agents use it for each of their properties. In Finland we work with Kiinteistömaailma. We have a contract with them. We do 50 houses per month for them. So they have, when they're selling a house, it's when they launch the house in the web, it's already online like this, so you can view it. And our vision as our company is to bring more and more of this to the market in Finland, also like kind of thinking about changing the whole brokerage system and brokerage how it works, since I think we will start to sell houses online more, not like you would buy a house online, but the sales process starts online rather than just dragging the people to the building first. So I think this is a great step in that, since this costs so little to do. But then we could show you the 3D model. It's just the Unity player where we can actually dig into the 3D mesh and see the quality of that. It's this is like not a public Matterport player, but I don't know if you can close it. But I don't know. Probably not. Yeah, it's all fine. But you can see this is the actual data that we can also export from Matterport. So if we're looking for hacks to do or something like that with Matterport, you can get this out of there like very easily. That's like what we were thinking, that if you could do something with Matterport, like you can work with this, like it's not closed off in the Matterport system. Like the other showcase, it's only coming from Matterport Cloud, so nobody gets really access to that data. But this is like data that we can share with you guys if you're interested. It's a OBJ file that we can export. But as you can see, the quality is decent. It's not super, and there are some errors of course, but it's still pretty amazing how good of a quality it can do in so little time and with such a little effort. But here's the comparison of the photo data and the 3D data.
Question.
Can
you improve the quality by taking more points?
Yeah, definitely. If you take let's say 200 scans, it's much more better, and it's very decent if you have empty space, but no furniture. It's very decent quality.
Yeah.
And it's about approximately one centimeter that the accuracy. Yeah, it's 1 centimeter plus minus.
Yeah, but there's a limit on how accurate you can make it with the scans. This is not the most accurate since it's a pretty big home we did. So we did like a scan every 3 to 5 meters. You can do scan every 1 meter, which is probably the optimal quality. But it's a little bit better, but it's not like a whole lot of better. There are always little errors since the camera can't see everything, and reflecting sides. There are a lot of trouble with mirrors and all these things because the camera can't understand what's going on.
Was there a lot of manual work on stitching the different partial scans together, or is it all automated?
It's all automated, yeah. So, and we should have probably brought the whole system here so we could have showed you, but it's how it works. You have the iPad and the camera rotates and it imports the data to the iPad, and inside the iPad it always does the stitching automatically, so it connects the dots. So in the iPad you don't have to input anything manually. You just start to see the floor plan coming together since the dots like connect to each other. And it's always a requirement also that if you do another scan, it has to link to the existing scans, so it kind of builds the model all the time.
So there is some kind of range that you cannot like move too far.
Yeah, it's like approximately 5 meters. So if I do a scan here and try to go away from like to outside that corner, it will say like scan not aligned, so you need to move closer. So
does that happen often when you're scanning?
Not anymore actually, but in the beginning that was like quite a problem. But what the camera is actually doing, it's always compared to the previous scans. So it's always compared next scan to the previous and take the data from the previous scan. So you have to it has to see the previous point, the scanning point. But it's really fast and easy process. Where the magic actually happens is in the Matterport cloud, where they have an algorithm which looks like stitching those scans together. There's the magic how they stitch their whole 3D model.
Well, we're really excited. This is the camera is like 2 years old now, almost, when they launched it, and they haven't launched their next camera, but we're just wondering like if they take this technology to another level, we could really simulate them being there, because it's still like a pretty good quality, but it's not like we have problems with some real estate agents. It says it's not like high enough quality. It's not like photo quality or like professional photography quality, but it's pretty close to that.
Yeah, and you can actually take a measurements also right now from our system or Matterport system. So, and it's good that there's 3D model, but actually Matterport don't use it like much for the commercial purposes. The main thing is that you can actually just move there, but there's like coming new features where they like using the 3D model to make a new features for the customers.
Yeah.
And we can show it actually for you what is coming on. Like there's a short video.
There's no talking in that. This is just
these features are coming fall, so I think that within a month we're gonna get these new features from Matterport. This is actually on live right now.
We've already got some of these. Some of them are kind of business related. I think Matterport has been moving to that direction also. Like it used to be very tech first, but now they're more business first maybe.
So you can actually move in the model within a Facebook, like it's same kind of like in the video. And Matterport use iframe and WebGL technology for the 3D model, and it's very easy to embed to any site, which is good for our customers. And you can actually highlight some like points from the house which are most interested points. But this is like cool new feature that you're gonna get those matter tags, so you can actually attach to the 3D model those kind of tags where you can attach like video, audio, links, pictures. So basically you can move around in space and there can be like tags like, okay, there's a cool sofa, I can click it and you can go to the IKEA and shop it. So it's like very cool new feature coming like within 1 or 2 months. But as I said, that they haven't used 3D model much, but now they are going really commercial way with those matter tags that you can actually use space for the marketing purposes and so on.
I think that was our official presentation, but if you have any questions, we are happy to answer, and like what you are interested in this space, technology. Or do you want to hear more about the process or business, or because we didn't really know like what part of this is interesting?
Yeah. One thing is which may interest you that is suitable with VR glasses like Oculus Samsung cooperation. And we have those glasses and you can actually move around in a couple of demo spaces with those glasses. So it's like straightly the model is like okay with the glasses, and but it's just demo right now, but I think that's coming soon also.
All right, if there are no more questions, thanks for your time. And
if you want to know more, you can visit unrealer.com or just call to us or drop an email, whatever, if you have any questions, or if you want to that we scan your house, we can do it definitely.
And if you want to play with the 3D model, we can send you the files, the OBG files, or like anything like that. We're happy to help. All right, thank you.
Thank you for that.
Yep.
Ei. Ajattelin vaan just tulee sitä tappyyntiä, mutta joo. Ei ole varmaan sähköpotlakin. Okay, then we have a couple of minutes left before the schedule says that it's Umbra, but I guess we can start a bit earlier. And we have Yasin and not Mikko, I guess, Lynn, who are going to present the technology. So please come forward. And yesterday we had also on the lightning rounds we had the short presentation of Umbra, and now a bit more detailed. And so you have background in gaming industry, but now 3D is going. It's very hot topic in everywhere.
Yeah, it is.
So the technology can be used in also in AEC areas. So let's see if we can hook up. Interesting piece of machine. Last week was also big week for Umbra. You got
we announced the funding and you know, our new ambitious plans.
Yes, you can tell that yourself. It was 3 million euros funding.
Yeah,
that's nice. Okay.
Alright, hey everyone, we're from Umbra. My name is Yasin and this is Vin. And we're gonna talk about what Umbra actually is and maybe how we could help during the hackathon as well. So first, just to show off a couple of games that we're in. So excellent RPG game called Witcher 3 uses our tech. Batman Arkham Knight also has Umbra in it running. Call of Duty Ghosts. Yeah, actually Call of Duty Black Ops 3 released yesterday, and that also has Umbra obviously in it as well, so that's cool. And Bungie uses us, so a lot of the tech has been co-developed with Bungie to be used in Destiny. And I guess, can't say anything yet, but next week is going to be a big week for us as well, so there's going to be some cool announcements. Maybe somebody else using our tech as well, so stay tuned for that. So, Umbra, I guess you could say that we're a startup, but in reality we've been founded, I guess, in 2006, so we're not exactly a young company. Roughly 15 people based in Helsinki where all the coding gets done. We do have an office in Seattle as well where Farhad is based on. And yeah, last week we announced our funding round, so we are growing rapidly. Well, not rapidly, we're growing like steadily, but not looking to expand like tenfold or anything like that. So, but we are looking for brilliant minds as well. So what do we actually do? I want to say, like, we are here to present our new tech, but I have to say a couple of words about occlusion culling, since that's the tech that the games actually use currently, and also because this is the tech that's been pre-integrated into Unity as well. So whenever you use occlusion culling in Unity, you use Umbra, and you can get this for free when you use Unity. So I want to say just a couple of words about this. So the way Umbra works is that basically you get an arbitrary 3D model, arbitrarily large, or consisting of n objects basically. We call this the polygon soup. We take this polygon soup as the input. We do some heavy crunching on it and generate this small, lightweight, optimized database that we then use in the runtime to do these various types of queries. The most important query that we do is basically a visibility query. So here's my camera, which of the objects in my 3D world are visible at this given time. And yeah, so this is a very, very high level overview. It's a voxel-based system. I'm not going to go into details about the algorithm itself. You can ask me if you're interested. But as I said, this is integrated into Unity already. And I wrote I think it was a year or 2 years ago, I wrote a blog post series into Unity's blog about what the parameters do and how it actually works. So you can check that out if you want. Or we're going to hang out here for at least a few hours more, so you can ask me as well. So if you intend to use Umbra in your project in the future. But yeah, so as I said, this is the kind of, or has been our bread and butter for a few years now. And right now we are actually doing some new interesting development as well. And we're going to show you guys a small demo of it. And then we do have the new prototype as a Unity plugin available as well. So if you do want to use that in your project, you can ask us and we'll give it to you and we'll help you to use it, because as I said, it really is a prototype at this point, so it's not quite polished in every sense yet, but you can try it out. So with that, I'm going to let Vin take over.
Yes, so as Yasin said, we are working on a new prototype that's built on as an extension to the current visibility system, but it tackles an entirely different problem. It's the level of detail problem. So let's So what you're seeing here is a city of Boston that we received from Google. And what's going on here is the camera is flying through the city in completely real time, and the content is being streamed in while the camera is flying. The interesting part, there's the original data. The original data is like 200 gigabytes uncompressed. So if you were to open it in your computer, you would need 200 gigabytes to open it. So what's the Umbra new prototype, what it does is it takes this content in and optimizes it and generates a different level of detail assets that we can really easily stream in on different devices like this laptop or maybe even a mobile phone. Stuff like that. So I can demonstrate how this works like behind the scenes a little bit, but the actual computation is really harder to demonstrate because it takes quite a long time, but I can show you the runtime version of this.
You say 200 or 2000?
200 gigabytes is the
uncompressed or compressed?
Uncompressed in the sense that, of course, the textures will be compressed like the XT1.
So the actual file is like smaller than 200 gigabytes?
No.
The file is 200.
Yeah, if you were to open, like put everything to the GPU, that would take 200 gigabytes of data RAM. That's what I meant. So if you have a lot of texture data, text data.
So basically the uncompressed geometry and the materials are 200 gigs.
Okay, so you have some smaller file on that laptop.
Yeah,
it's not streaming stuff.
No, it is streaming, yeah. We regenerate the geometry and the material, so that's what the prototype actually does.
So I can show you a little bit what's going on. So here is the entire city, and of course currently it's running like in real time. And I can also put the visualization of like which level of detail is being chosen. Just a second. So here's the camera. You can see it's moving to the left, and the system like chooses. So now the camera has moved to a different location. So what I was about to say is that the system like chooses the best level of detail depending on the distance to the camera. So currently, as you look at this, it's like trying to stream in all the generated assets that we used the prototype generate from the original data. I don't know if it's anything else to say, really.
Yeah, well, yeah. We had this demo running on like an Oculus device last week, and we still do. We don't have the Oculus dev kit with us this time, but yeah, this is like Google Earth data, which we regenerate and resample to provide this hierarchical LOD representation of the entire world, and basically combine this with visibility, streaming, and LODs. So that's the kind of universal turnkey solution to. The vision is to basically being able to render any 3D content on any device, because the user gets to choose the budget and we generate the data that fits the budget. So that's what the system does.
I just want to be clear, are you streaming the geometry from some cloud, or is everything on that laptop?
So in this case we are streaming it from the disk.
Okay.
We will provide a cloud-based solution as well. So
it's not implemented yet, or it's work in progress?
No, the cloud system is work in progress, yeah. So we have the computation running in the cloud, and actually this Boston model is something that you really cannot compute even on a local machine. So we already do the computation on the cloud, and we download the regenerated 3D meshes from the cloud, but we don't have a system that actually does it like dynamically streams it on an on-demand basis, basically.
So I assume that cloud-based version will work something like Google Earth, where it starts to kind of you get the higher level of detail.
Exactly. So basically the same way as you when you look at, let's say, a video stream. So first you get the low resolution version, and then higher fidelity as you proceed to download more and more. That's the idea exactly. And that's what, like, if you think about a world like this, there's like basically no way that you can actually fit the, any version of the original model on an iPad, let's say. So that's the idea, is that somebody authors the content some way or generates the content some way. We automatically like process it in the cloud, and then from the cloud you stream it on an iPad, so you can go to the construction site and move the iPad around and see what the actual 3D model was supposed to look like, even though you don't have the original authored or generated content on your iPad, because that wouldn't fit there.
Do you have some bandwidth requirements for streaming something like this?
It's too early to say. Yeah. And as I said, we're going to be hanging around here, so if you have any questions, you can ask us, or want our help with the Unity plugin or the Unity occlusion cooling system, we're here. I guess that's it, right?
Yeah.
Yeah, thanks.
Okay. Okay, we have plenty of time in the schedule. So, now there's an opportunity if somebody wants to present something, because we have plenty of time. Otherwise, we could take the last presentation, which is the 720 degrees. If Thomas is ready. Yes, you can take that. And if somebody wants to say something after Thomas, it's possible. Okay.
Hello. My name is Thomas from 720. We are providing data source as well here, and what we focus on is on built environments. So on the indoor environments, and we then analyze how does it impact the people in the buildings. We are helping the organizations to understand what's going on in the building, and also how they can improve. The reason why, and it was a topic of the talk actually on the other track of the workshop, what's important is that we focus a lot on kind of the assets and energies, which are very minor proportion of the total cost of the total operation of the building. The major cost are the people, and the building should serve the purpose of the people. So there is a new trend to refocus on fulfilling the needs of the people first, and then focusing on optimizing the utilization of the resources. And that's something what we are working on. So we are combining data from indoor air quality, acoustics, behavior of the people in the buildings, and we collect their inputs, the subjective perceptions, how satisfied are they with the environment, how does it support their needs, and then we analyze everything, or combine the subjective, objective data to analyze them and help companies to improve the performance, but in terms of people primarily, because people are the ones who create the organizations and who create the value in the organizations. How does it work? And you will see our sensors around. Here are a few, and they're also in other room and upstairs on the 6th floor. So we have devices which measure different parameters of the air quality that you will see from the data stream and from the specification: temperature, relative humidity, carbon dioxide, volatile organic compounds, which are chemicals, particles which make you cough and sneeze, and particulate matter, dust particles in the air of different sizes. Also, which is not there yet, but we have acoustics here, so you will see the stream of noise levels evolving over time, and whether the noise is from the machinery or whether it's when people are talking. Maybe one of the... Okay, well, my computer is a bit drunk, I guess we can. Anyways, what do we use the data for? We analyze them for our customers. Some of our customers are Danske Bank, YIT, Microsoft, Nokia. It serves the purpose that if you have many buildings in the organization, it's very difficult for the facility manager or real estate director to know what's going on at all the workplaces and which are the ones he needs to pay attention to. So through that we manage to kind of automatize everything for them, give them the right notifications, and explain what is the difference between how you as an occupant feel and what the real estate is providing to them. I guess that this is not going to work. So there are different ways how to utilize the data. Now you can imagine what we do. But it's used for prevention. So for instance, if your HVAC system is malfunctioning, so that the data or the sensors notice that, and we give you information or when something is happening as well. Or then when you want to optimize in long term, so you want to relocate and you want to look at the data and say like, okay, I want to relocate these people into a new building. What kind of a new building I need if I double, for instance, the head count? I can skip till the end and more to the questions. We are about 10 guys working from Valila from GE Healthcare. We have a nicely international team with background in anything from computational chemistry, two guy from Rovio. And actually, and this is not visible, but also we have a lot of positions open, so if you are interested, check out our website. I'm sorry about the slides. You probably have to check the website, or then please ask for any questions you have. This is weird, but yeah. Questions?
So how can we reach the data of the sensors we have here?
Great. Could you help me?
Yes. We have the document, which is you can find it. I can send it to you, but there's on Slack we have shared this document that contains all the resources that we have for the hackathon. So it's a big list of different things. So there's also 720 is also included there. So there's a document describing the API, how it works, and yes, and there's some usernames and passwords for you to choose.
Okay, I can find that.
Yes.
I think it's in IoT channel in Slack. You will see also the floor plans and where the sensors are located and what are their names, and then you will see the documentation. There is Simon can't be here from our team, but he's on Slack. So if you poke Simon, he will answer any technical questions regarding the API.
Yeah, we have had these devices since Wednesday, so we have the historical data also. It would be interesting to see if somebody could visualize how, for example, how it's different from day to day, and for example, to see how this hackathon develops. I mean, in different levels. So, but of course, you can have different ideas. But if you want to see the device, there's one right behind.
There are hidden behind
so there's the device is measuring in this area, and auditory is one, and then also in sauna area.
very common idea what is to do to our sensors to go there and breathe on them. There is slight delay, of course, because it goes through our cloud and it buffers the data, so you need to wait for a while to catch your breath also in the data stream, but just that you know, it works.
It would be very interesting to see yesterday's kick-off presentation and kick-off the whole event, that how the CEO and all these different levels goes up and
I think this is the first hackathon where we are measuring where actually they let the ventilation work in. Usually they switch off the ventilation at 7 or something, so by 9 p.m. there is usually terrible indoor air quality. In that sense, it's good for you when you're coding here. It's not that interesting from the data perspective because it's not so screwed up. But you can do some tests, so maybe you will figure it out. Any questions? Okay, thank you guys.
Thanks. You have a question?
Still on? Yes.
Are you linking this to measuring also the staff productivity?
Sorry, product?
Are you linking this to also measuring the staff productivity?
That's a long-term goal, and that's what all companies would love to see. It's very difficult because your productivity is extremely influenced by the organization and how you work and teamwork and colleagues and everything. So it's difficult to do that. But, so what we would like to, for instance, what we would like to test is more like link it to the, for instance, stress levels, right? So if you're exposed to noise or bad air. And then there are tests how to link it to productivity through cognitive performance. So for instance, Harvard published 2 weeks ago a study where they were testing people how far they can read and write and how many mistakes do they do, how quickly can they do decision based on how bad the indoor air quality was. So, but the problem, it's a lab study, it's very difficult to do the field study. But if you have any ideas, we would love to see that. That's an ultimate goal, probably many years ago. Thank you.
Okay, thanks everyone. That's pretty much this tech track, and we have now 20 minutes till the lunch, and 20 minutes for you to do something interesting and hack. So let's see. And there's also some the presentations on the auditoria side still ongoing. Tim, do you have something?
No. You run panel?
Yes.
Yeah. Okay.